All right. This is a fill-in session. We had a few speakers go missing for various reasons, and so they asked me if I'd pick this one up. I wrote it a little while ago, and I had to refresh it because we're in such fast motion right now. It's remarkable. And I'm playing with the name. On Becoming seems a little pretentious. Maybe just next steps, because we are on a path right now, which I find fascinating. My name is Richard Campbell. That's my Twitter handle, because I'm resisting calling it X. I don't like that much. I make a lot of podcasts. Any .NET Rocks listeners? Oh, wow. Okay, great. Thanks for coming out. This is because of .NET Rocks. So my friend Carl started .NET Rocks back in 2002, which predates the word podcast by 3 years. I'm the new guy. I came on board for episode 100 in 2005, and 2 weeks ago we recorded episode 1900, which was with Scott Hanselman. And we actually pulled clips from all of the old Scott Hanselman shows and made him decide if he'd really said things, and then we played back the clip, and he got them all right. And I occasionally exercise my IT brain as well, so since 2007, I've been doing a sysadmin show called Run As Radio every Wednesday since April 11th, 2007. And then the tablet show was a brief interval of 3 years when we weren't sure if .NET rocked, and so we wanted to talk about tablets and mobile and stuff separately, and then rolled it into DNR when it turned out that .NET was just fine. All guest-based shows where we bring in a luminary, smart people on that. But this geek out stuff came from .NET Rocks. So back in 2011, Carl was listening to me on the phone. We weren't recording when I was complaining about how bad the shuttle was. Shuttle was landing for its last time. There was lots of problems with the shuttle. And he said, I don't think a lot of people know this. Why don't we make a show about that? Which I thought was a really bad idea. But it turned out people liked it. And so this is a picture from the old site. We've got about 100 geek outs now. So these were really based on what the audience wanted to hear about. I'm interested in everything. I take a lot of notes. My OneNote is very extensive on a lot of subjects, and actually making these hours were a way to consolidate thinking, sort of get it down to, it's fun to explore, but like, how would you explain this? And so for me, it's very rewarding to knock down those hours. That top one there, the moon-based geek out, was the one where a few months after I made that show, NASA called, which is a pretty good day, and asked me if I would talk to them about building bases on the moon. And I'm like, sure, but, it's your stuff. Anyway, now I got to go to NASA and do a presentation on building bases on the moon. So, and then later, other conferences asked me, like, would you do that talk for us? It's like, it's not .NET. But, yeah, okay, no problem. So this talk is basically derived from that, because we've come a long way from 2017. And the first question you got to ask is, why should we become a spacefaring civilization? We got enough to do down here, quite a bit to do. The obvious one, the obvious answer comes, all the way from Carl Sagan, which is that the dinosaurs died out because they didn't have a space program. Our best shot of staying on this planet for an extended period of time, we've been around a couple 100,000 years, is to actually conduct this planetary defense. And we have a group of folks, mostly Americans, that do exactly that. They are in the role of how do we deal with planetary defense, and that's mostly focused on asteroids, which is interesting. And we have been making progress in this area. If you've been following the space program lately, there was the DART mission. And the DART mission was a test to say, can we alter the trajectory of an asteroid? Is this even possible? You've seen it in the movies. You've watched Bruce Willis do it. But could we actually do it? And the answer is yes. So this is a binary asteroid system. The smaller asteroid orbits the bigger one. And the reason we picked this asteroid pair is because we can see them clearly with telescopes. So they come close enough to the Earth on a routine basis that we know the period of Didymos, which is the smaller asteroid. And so the idea was, let's take a satellite and smack it into it, as the NASA scientists say, with vigor, and see how much you can alter the period. And the period, I think, was about 22 hours. And so this is actually photographs taken from the impactor satellite coming towards the bigger asteroids down below, the smaller ones there. This is sped up, so they're just taking photographs and sending it back to Earth over and over again. as it gradually gets closer. Our ability to calculate trajectories is really, really quite good. That is not that big of an asteroid, and this is a very small vehicle, and they've got the thing centered. So this is a 5-minute run. Didymos is the bigger asteroid. What they call the Diddy Moon is the little one, so about 160 meters across. And here we go. We're getting awfully close. So this is a 550 kilogram satellite. Didn't quite get to send that last frame. Now, cleverly, they had a pair of nanosats attached to the bigger satellite that detached about a week beforehand, so they were on the same path but somewhat behind, and so they were actually able to record and transmit video of the impact. So, this is not your high-grade HD stuff, but it definitely worked. So the Leica Cube did the impact, and the goal was to change the orbit, which typically about 12 hours, had been about 12 hours. They were hoping to shift it by a minute. They thought maybe 73 seconds, and they got 33 minutes. They also kicked a rubble pile out of it. We're coming to appreciate that asteroids are mostly aggregate. They're just bits of rocks that are just hanging out with each other. And so that impact effect through all of the rocks seems to have telegraphed a lot more energy. So it changed the mass of the asteroid substantially. It created they figured push about 1,000 tons of rubble off of the smaller asteroid and left a trail about over 1,000 kilometers or 30,000 kilometers long. It's not a lot of gravity involved in all of this, so it's sort of spread out. And it's a beginning of teaching us more about working with asteroids meaningfully. Like we're on a path to, with the planetary events groups, that we could detect an asteroid in sufficient time to say this is a potential collider and let's do something with it. Now, smacking into it with kinetics is one way. I would argue the more effective way might be actually just to mine the value from it, right? And this is part of becoming a spacefaring civilization, is that we should be doing resource extraction. So far, we've only been using resources from one place, here. And while it's plentiful, it is also finite. And there's been some papers recently written that said we probably have about a 50-year window to really establish ourselves in space before primary ingredients necessary for that become too expensive to make it practical. The process of developing infrastructure is costly. The only way we got rails across Europe was public investment, the governments investing in the rail systems. Ultimately, they became profit centers, but they aren't at the beginning. And so that same sort of establishment of infrastructure is important. Now, and the Americans have been busy about it, right? They're doing a lot of things here. This is a mock-up image, but it really speaks to the idea that some people are explorers, that our civilization is better when we can send crazy people off to crazy places, right? Don't keep them too close. They do crazy anyway. And most of us have not been in space. The typical American astronaut has 3 PhDs. Because there's so few of them, they get to skim from very rarefied folks. And they're strange humans. One of the stories that came out of building the space station was that because they're in these pressure suits, so their gloves are a really complicated part of the suit, they've reduced the air pressure in them because they're literally in balloons that are tough, and they have to flex their fingers through them. But they had a problem with their fingertips bleeding because of the fingernails. There's so much pressure as they're trying to manipulate things while they're building the station. And so a group of the spacewalkers that were doing a lot of these spacewalks had their nails surgically removed. For the 4 or 5 times that they were going to spacewalk in their lives, they wanted to be at their best, so no fingernails. I'm not that guy. Most people aren't that person, right? So it's good that we can have a place for the frontier folks to go that are willing to have their nails removed and things to do these crazy things. But if we're going to actually establish regular folks going out there, we need these pioneers out there to make those next steps. All right, let's see where we are and where we can get to. So I'm going to reference Heinlein there. It says once we get into Earth orbit, we're halfway to anywhere, which is a good line and fine books. A lot of folks get fixated on the idea that we should build a space elevator. So this is the idea of a cable, a tether that runs from the surface of the Earth into space. Geostationary orbit's about 36,400 kilometers up. You need to go further than that because you need a counterbalance point, but that would be the sort of center balance point of it. So it's not actually being held to the Earth per se, that it pretty much is in balance at that point. There's a few problems with this idea. It's very cool, good science fiction material, some great books written around this. The tensile problems are so high that making a material strong enough is almost impossible. But we have found a few materials close to this, some carbon nanotubes and things like that. It's just that you need to make a whole lot of them, about 40,000 kilometers long, to be able to build that, and that's fairly challenging. There's weather, which creates some oscillations, but arguably the most difficult one is it's a really, really, really long cable, and you've got to run an elevator on it, and that's going to take a while. We're talking days. And along the way, you're going to pass through the Van Allen belts, and they're going to cook you in your skin. We haven't sent humans above the Van Allen belt since Apollo, right, since the missions to the moon. But even when we sent those guys back then, we did it at speed. We deliberately did highly elliptical exits out of the Earth so that we minimize the exposure to the Van Allen belt, and we did them very quickly. They went through the Van Allen belts in a matter of minutes, and it still was their primary radiation exposure, more than the hard space. Getting out of the radiation fields around the Earth is a big deal, and an elevator needs to be at the equator, so it needs to go through the thickest parts of the belts, and slowly, because it has to move up a cable. We're not going to do this. It doesn't make sense, and we may not need to, because there's this billionaire. Don't know if you heard. Listen, I got a lot of problems with Elon. I miss old Elon. You know the guy who flew his sports car up to Mars? I like that guy. That guy was kind of fun. This guy's a nutter. But you can't deny what he's done. What he's done to the electric car is profound. He's made the rest of the industry take electric cars seriously. We're in a different time. And what he's done to space is profound. The Falcon 9 is now the preferred vehicle for any payload that has a choice of lift vehicles. You will use a Falcon 9. It is dramatically cheaper. And it's because the first stage lands. It comes back and they refurbish it and fly it again. They've flown a few of them more than 20 times. They've landed over 300 times. It happens so often, it's not even news. He now has flown more satellites in space than the rest of the world combined. He now has more operational satellites in space than the rest of the world combined. Humanity's flown roughly 6,000 satellites before Starlink started. About 2,000 were in operation when he started. He's now flown 9,000 of those, of which 6,000 are operational. And for $120 US, you can have internet anywhere you want because of Starlink. This is Starship, and there was just the fourth test of this particular vehicle because our boy's going for it. It's a 9-meter rocket. It's the largest structure ever sent into orbit by a long way. His goal is to make a fully reusable vehicle. So he already knows how to land first stages. He did it with Falcon 9. They had a pretty good example in IFT for landing the lower stage. But nobody's ever recovered an upper stage. The closest example would be the space shuttle, but it had very serious limitations. IFT4, if you followed it, wasn't far from perfect. They lost an engine in the first 3 seconds. The good news is they had 31 of them, so they didn't actually need it. They can lose up to 3. So there's some redundancy there. The flight plan, it was a test flight. So the goal was 2.5 minute boost by the lower stage. Then the lower stage separates, boosts back, and in theory would land back on land again. And this one it actually tested landing in the water. It was within, they think, about 100 meters of its designated landing site, which is pretty impressive. And then the upper stage never fully went into orbit. It was at orbital height, but they didn't round out the orbit. It's pretty normal once you reach your apogee, you would then do a burn to circularize your orbit and stay, and they did not do that, and it was intentional. So that if anything went wrong with the upper stage, it would naturally deorbit. They left it on that path so that it would automatically deorbit in the Indian Ocean close to Western Australia, which it did. And they did the question was, can you re-enter an orbital velocity vehicle that large? And the answer is yes, it went pretty well. Remarkably, we've never really seen re-entry video like this before, but the Starship is so large at 9 meters across that their antennas to Starlink are still visible through the plasma field that's created by the re-entry. So we've been able to watch these re-entries. And if you've watched the video on this, you saw the little flap that could, right? That they had a camera that somehow survived, not healthy and happy, but survived, that showed the shielding on the flap failing, but it ran all the way till it made it to the ocean and they made a landing. I was not going to bet on this. This seemed unlikely. But it's a 100% reusable vehicle. It speaks to the possibility of substantially lowering the cost of flight. So here's the only number set on this whole deck. Atlas V is a rocket from the 90s. We just saw one fly again with Starliner. They are obsolete, and there's only a half a dozen of them left. They'll never fly again. In the 90s, it was $25,000 US per kilo to low Earth orbit for an Atlas V. They got it down to $8,000 because of Falcon 9. Falcon 9 is down in the $3,000 per kilo range. Falcon Heavy is lower than that, although it tends to be more expensive than that. They've flown one Vulcan so far. This number is speculative at $9,500 a kilo, just because we don't really have pricing for it yet, but they've flown one, so we're getting there. New Glenn is a rocket that's never flown, so all of its numbers are lies. Until you fly it, what do I know, right? And then the Space Launch System, this is the American rocket to go back to the moon. This is repurposing shuttle technology, because that's a good idea. I mean, here's the reality, is that the Americans have so much money they can afford to be this stupid. NASA very cleverly made sure that the space shuttle program involved every state in the Union. So there are workers in every single state in the Union that would contribute to a shuttle flight. When shuttle was shut down in 2011, because it was just simply too dangerous, it killed 2 crew. And it's not that we're running out of astronauts. We've already established that astronauts are nuts. They'd run out of orbiters. They only had 3 left, and you really need 4. And so they retired the orbiter. But to keep all of those people employed, they insisted that NASA build a vehicle based on space shuttle technology, knowing it would keep all those people in all those states working on it. They only funded enough to keep those people working, not to actually build something. But it turns out if you waste enough time working on the same thing with just barely enough monthly, eventually you build one. And so we do have a price for, they've flown one. And they're about to fly a second one, but it's $4 billion a flight. Right? A Falcon 9 flight without crew on it's about $40 million, depends on the negotiation. The rough price for flying to the space station with 4 seats on a Crew Dragon is about $100 million. And there's actually been a couple of tourist flights, like Jared Isaacman has rented one. It's nice to be a billionaire. Oh, $100 million? Sure, can I bring my friends? So save up, but you can get a flight on a Falcon 9. But yeah, $4 billion to fly space launch. There's a speculation for what Super Heavy could actually be priced at. If it's a fully reusable vehicle, so that it just needs maintenance, if you just look at the cost of fuel is trivial. So I've seen estimates as low as $7 a kilo. It'd probably be $100. But at $100 a kilo, you can afford this, right? This is now, I get to go to space for a week for the price of a sports car, right? Not the price of, being a billionaire. So it is transformative. It opens the door to a stunning amount of stuff being lifted into space and different things being able to go to space. And it is a requirement, if we're really going to go down this path, that we have to be able to lift efficiently, right? It took a lot to build this space station. It's the largest thing we've ever put into space. It took 20 years to build it. First components went up in 98. It weighs about 400 metric tons. Starship could lift it in 4 flights. So, although even NASA says we'd never build a station this big again, it turned out to be a mistake, right? This is a microgravity laboratory, but they spent an amazing amount of time just trying to find stuff because it's big enough that you don't know where stuff is. So they want to and you got to find it because going to the store to get more is hard, and it takes 3 people to operate it. So now that they run 6 people on it, they're actually doing a lot of science. They've learned a lot about how humans function in free fall, which is to say poorly. And it's getting old. Stuff's starting to crack, especially on the Russian parts. Mold is growing inside vessels and so forth. It's essentially unmaintainable. They could swap out the oldest parts for newer parts, but NASA's doing the right thing. They don't want to own space stations anymore, any more than they own access to space anymore. With the cargo missions, they now pay per ton to lift stuff to orbit and back down, and now they're paying per person to fly people to space rather than own the vehicle. So they want to do the same with the stations. So they have this commercial space station proposals out there that a bunch of companies have responded to build a bunch of smaller space stations. Because often these science experiments don't overlap. Microgravity experiments don't like things that make the station shake. So better to have smaller untended stations, or just tended stations, not inhabited stations, to minimize microgravity effects. If you want to experiment with centrifuges, that should be a separate station. And so what we'll see in the next decade or so is far more space stations. I mean, there's already 2, right? Don't forget the Chinese have one. They're basically building the equivalent of Mir right now. They've got 6 people on it at this moment. But we will not have something as big as the International Space Station until a lot changes. We will have a bunch of small stations with easy lift. One of these, inevitably, will be a hotel. I would bet on Axiom Space, these folks all the way on the far side there. This is a bunch of ex-space station guys from NASA. They are actually they've got the first components under construction now. They're actually going to assemble their station attached to the International Space Station as a tourist area over the next few years, so a billionaire's playground. But with the goal that before they deorbit the International Space Station, they will detach. And now apparently some proposals to take some of the newer space station modules with them. So Discovery, the American Lab module, should have another good 10 years of it. It's just that they could, oh, who didn't turn off their phone? Point and laugh. The largest of these station designs is this one here from Origin. That was pretty quick. This is called Orbital Reef. This is actually be 3 of them attached together. Those are 7-meter diameter cylinders. In the International Space Station, they're 3.5 meters. They're quite a bit narrower. These are way bigger, which is actually a problem. You have to fill them in. Because if you are in free fall and you end up inside of a chamber where you can't reach anything, you're stuck. What are you going to do? So they're talking about filling in the inside of these bigger chambers because you need to be able to touch stuff. My favorite gadget coming out of the development here is from Generac. It's this, which is basically a micro spaceship. So one of the problems with spacesuits is that because in order for you to operate in them, they are lower pressure, and so it takes 3 people to get you. There's the astronaut and 2 people to get you into the suit, plus several hours of pre-breathing oxygen. You know, all that science. You remember Mark Watney on the Mars putting his own suit on? Lies! Mark Watney's dead. Very dead. And this is after you're running at normal pressure. So this would be you climb through the thing, close the door, unlock yourself, zip out to where you need to be, where you at least can have eyes on, but you'll be using manipulators, not your hands. So it's an interesting idea and something very practical, a lot simpler than these kinds of suits. Actually, I've ran through all these. This is the untanded suit. There's a little micro robots around this thing to do maintenance on it, but people would just visit it every so often. Mostly it'd be by itself. And there's the Axiom Space design attached to the space station. So that innermost module is currently under construction. Those parts are being assembled right now. So they're probably 2 years away from flying that. And then check out the glass dome at the bottom. Right, that'll be a view. And then, yeah, they might be taking parts of this system away with them. So it'll be a free-flying space station in the next 5-6 years. Okay, so more people in orbit doing more things is good steps towards spacefaring, but it's still just hanging out around the Earth. Let's talk a bit about the moon. This is my favorite picture of the moon. It's a picture of the far side of the moon, not the dark side, obviously. The question you should always ask when you see a space picture like this is, who took this picture? That's a funny spot to be at. This was taken by the Discover satellite, which is a sun observation satellite. So it sits at the L1 between the Earth and the sun, so that it always has a view. It's literally between the two. So it always has a view of the sun, and it has the Earth always directly behind it, and it just follows around in the orbit of the Earth around the sun in that location. And it's for sun observation. So you remember we had the Great Northern Lights recently? That was one of the satellites that gave us warning that coronal mass ejection was on its way to us. So we had a few minutes warning. A bunch of satellites pivoted to minimize their exposure. Like, we do react to big solar events like that. But on the back of the Discover satellite is a telescope. And it is a telescope because the Discover satellite is 1.5 million kilometers away from the Earth. But somebody thought, hey, we always have a disk view of the Earth from that satellite, so let's just take pictures of the Earth on a regular basis. So you have this great view. It's not very fast. The photos are every few minutes. And it's actually not full color. It's a single color camera, but they have different filters that they can put in front of it. So to make a full color picture, they actually have to take 4 photographs. And every so often, the moon whizzes through the frame. And I do mean whizzes through the frame. Like typically they only get 2 or 3 pictures of the moon over the course of its passing through. And part of the way I know this picture is true is because if you got real close to this, you'd see that the edge of the moon on the right side, little green halo. And that's because the green photo is taken last, and the Earth had moved, and the moon had moved, because it moves, it buzzes through the frame. So it's a real picture, and it makes, far side of the moon, not dark, full of Chinese spacecraft right now. We've been to the moon, right? That was the Apollo missions. Well, to be clear, 12 white men have been to the moon. 11 of them are test pilots. Only one of them was not a test pilot. It's this guy, right here, Jack Schmitt. Jack Schmitt's a geologist. He's still alive. He's in his 80s. So Jack was supposed to be on Apollo 18. He was the only, remember, we know perfectly well the Apollo mission was all about the Americans showing off that they're tougher than the Soviets. I'm sorry. And so that's why they sent military test pilots. But they called it a science mission, and they did have some scientists, and Jack trained all the test pilots on how to look for rocks. But they also said we should send Jack. And so they're going to send him on 18, then they canceled 18, so then they moved him to 17. And so he went up with Gene Cernan. So he's the only scientist to ever set foot on the moon, and he's a geologist. So there's a picture of Jack on the moon. You'll notice he's dirty, and there's a good reason, because he likes rocks. He got close to the rocks a lot. He's actually the only one of the Apollo astronauts that we've ever got a picture of someone's face from, because he kept lifting up his gold visor to look at the rocks. Now, that gold visor protects his eyes from the sun. In fact, your eyes will be burned out instantly if you look at the sun without that visor. And you can hear the recordings during Apollo 17 of Capcom saying, hey, Jack, when you get a sec, would you lower your visor? Leaving off the you dumbass part, right? To the point where you look at on the side of the helmet, right there. See that? So those are cards off of his arm. So every minute of the time on the surface is planned out. They only had 3 6-hour sessions on the surface of the moon. So every minute of it's planned out. They're on cards. Each minute, what you should be, next science experiment, trying to keep up with all these things. But Jack wanted to look at the rocks. So he started, as he finished the card, he ripped it off and stuffed it inside of his helmet so that he could block the sun and lift his visor and look at rocks. He's a geologist. And he found the best rocks, because discovery is not done by, Eureka, I found it. Discovery is done by, what the hell is that? And he knew enough about rocks to know a weird rock. And he found weird rocks. It's the only time we've seen a scientist in an environment like this. Imagine if we had 6 of them for a month on the moon. We had one guy scripted down to the 5-minute interval over 3 6-hour shifts. He broke all of the rules and discovered the most important things. He proved categorically there was volcanic activity on the moon. He found the rocks that were the evidence. He found unshocked olivine. And if you're a geologist, you're like, holy cow! The rest of us like, rock. Anyway, why did we end the Apollo program early? Mostly because of this machine. The Lunar Excursion Module was incredibly dangerous. There was a whole bunch of failure modes in this vehicle that were not recoverable from, and fortunately none of them happened. And there was no way to save them. That vehicle was keeping them alive for 3 days, and it takes more than 3 days to get there. So they just got lucky with Apollo that nobody died. It was the equivalent of running in traffic. And just a few times they did it, nobody got hit, so they stopped as soon as they could. And we haven't gone back because it wasn't worth the risk. But technology's evolved, and we have a new space program. Artemis is the name of Apollo's sister, right? And the Artemis Accords are built around this ridiculous spacecraft, or ridiculous vehicle, and a lot of nations have signed on. They've now flown Artemis 1, so that rocket's flown once with the Orion capsule. There was nobody on board. It wasn't a wasted mission. It seems silly, but they were doing a lot of orbital experiments with that Orion craft that we've never done before. So one of the things that's happened since the 70s, that last Apollo flight, and now our computing has gotten way better. We understand orbital mechanics far further, and so we did serious experiments with very precise orbital maneuvers with that vehicle with nobody in it, and learned a lot. Still a very expensive way to go, but the next mission, Artemis 2, is planned. It was originally supposed to fly in 2023, then they bumped it to 2024, And they bumped to 2025. They're still saying it might be November 24, but it seems unlikely. This time they're not going to land on the moon. It's just going around the moon. They're going to recreate Apollo 8, essentially. They're not going to do all the cool maneuvering. They're going to do a free return trajectory. So literally put on exactly the right angle of flight so they can go around the moon and come back to the Earth without having to fire a single engine the entire time, for safety reasons. There's lots to test here. They need to know the life support works. They're checking on navigation systems. There's going to be 4 people on board the vehicle this time around. It's a bigger vehicle. One of them is a Canadian, which amuses me. And then the third Artemis, this was the one that was supposed to be in 2024, and then 2025, currently they think in 2027. Because this is supposed to land on the moon. Only they're not doing what they did with Apollo, where they have an all-up rocket that has both a lander and the capsule on board. They're going to fly the lander separately, and they're trying to do commercial landers. And so there was a bunch of proposals for a lander, and the one that won was Elon's. So this is a modified version of Starship designed to be a moon lander. It's just that it's 150 meters tall, or 50 meters tall, 160 feet tall. So all of this is tank. This is the people part. So there's an elevator here, because that is one heck of a step. Those are people down there, right? Like, I hope you found a flat spot to land, because you're landing a 15-story building. So land carefully. And it's behind. It's very challenging. Part of the way that this is supposed to work is part of the whole Starship concept, which is you're going to get it into orbit, then you're going to have to refuel it to get it to the moon. At one point, they said it would take 10 refueling missions. Now they're thinking about 6. But that's still, you have to have a fully reusable rocket for this to be impractical. But the real question you have to ask is, like, how many times have we ever refueled a vehicle in orbit? And the answer is none. This is new science. We'll leave the innuendo out on this particular talk, but the whole point here is we have to figure out how to transfer fuel between 2 vehicles. And the problem is free fall. This is a video from inside of a Falcon 9 liquid oxygen tank during its lift into orbit. Can you tell when it turned off the engines? You can't pump fuel when it's sloshing around like that. You have to be under continuous acceleration. Here's another idea, end-to-end. I don't know why this doesn't call HR as well, but you would have to accelerate this in some way to have the fuel settle at the tank and the tanks to be pumped, which means you're also changing the orbit. So it's a constant dynamic system, and that's very problematic. One of the best ideas out there is don't lift the vehicle that needs to fly to the moon and then fuel it up one at a time. Build a fueling depot. When we start talking about becoming a spacefaring civilization, we start talking about infrastructure, bus stops, rail lines, that kind of thing. So the idea here is you have a rotating structure. So your tankers dock to it and you either keep the fuel up there or pump into a central point. Then your vehicle that needs the refueling can dock to it as well, fill it all at once, and then off it goes. And when you need to settle the tanks, you just make the structure turn. Doesn't have to turn very fast, just enough to make the tank settle. So build out a little infrastructure this way, and you suddenly have some choices. Build a few of these, and now you also have a marketplace. You think you can get fuel to my station cheaper? This is what I'm paying per ton for liquid hydrogen, or liquid oxygen and liquid methane. You want to bring it from the moon? Knock yourself out. Doesn't matter, right? The nice thing about a refueling depot, it's also a place to buy cigarettes, right? Like it's a waypoint that allows other options, not just at the moment. So you can experiment. We have proposed building fuel stations before. This is one from 2011 based on the Atlas V technology. So that's a modified Atlas V rocket. Now the problem here is that the upper stage of the Atlas V actually uses liquid hydrogen, which is a very efficient fuel. It's also low in density and needs a lot of cooling. Liquid hydrogen is only a liquid in about a 7-degree temperature range, from 3 to 11 degrees Kelvin. Any lower than that and it freezes, and any higher than that it boils, which makes it a very tough, water at least has got a 100-degree play. But, liquid hydrogen has a tiny little play, so it's very difficult to manage. One of the reasons we like methane rockets these days is because liquid methane and liquid oxygen are very close to the same temperatures. The methane's slightly colder, but it's not. You can protect it with insulation. Where hydrogen's wildly colder, and it uses the same condensers to retain it. Like a lot of stuff gets simpler. It's very difficult to liquid hydrogen. Anyway, we were talking about being on the moon. So we got this giant vehicle. The upside is it's fully reusable. No parts come flying off it. It's hard to build a base on the moon if every time you land, you leave part of your lander behind. Eventually, the parking lot is full. So at least a one-piece vehicle. It also carries more than 100 metric tons, so it can carry a lot of stuff. It's maybe a little awkward, but it's got flexibility. This is the competing design where the booster, they've actually modified this a lot now, but this has got a descent stage with the cargo on it, and then that's the only part that goes back up, just the ascent stage. So you're basically leaving a small building behind each time you make a landing. Actually, this picture was made by the United guys to talk about going to the moon, and the most important thing in this picture is the fact that that astronaut is kneeling, because it was impossible in the Apollo suits. The Apollo suits were basically bubbles. If you ever watch the video of them walking around, they kind of do one of these. They're Michelin manning it, right? It's very hard to bend your knees. So one of the things that's changed in suit design now is to decrease the amount of airspace inside there, to constrict the suit so that you actually have some flexibility and be able to move around better. It's also one of the pacing items for sending people back onto the surface of the moon is that these suits are incredibly hard to build and they're fragile. The longest a suit has ever lasted on the moon is 18 hours. And by that point, it was largely destroyed. The lunar regolith is a very fine grit that is bad for your lungs and bad for your suit. It sticks to everything. It's electrostatic, and it's an abrasive, and so it destroys suits. And they want to have suits that last hundreds of hours. So one of the ideas is because it's electrostatic is you're actually going to walk through an electronic shield shower that'll blow the dust off of you electrostatically. There's also an idea, and this suit applies that design, where the box on the back actually fits into a holder, and the suit stays outside. That then opens into the pressurized chamber on the inside, and you pull yourself out of the suit, so that we don't have to bring the dirty suits inside. Again, Mark Watney would be dead. There are percloids in the soil of Mars. They would have infected his thyroid, and he would have died of thyroidism within a month. Don't bring your suit inside. Suit bad. The base they want to build on the moon is on the South Pole, in the Shackleton crater especially, because there are areas on the Shackleton crater that are continuously lit, and there are areas inside the crater that are continually shaded, and they think there's billions of tons of ice inside there. This was a design presented by Blue Origin. That's a view of the Shackleton crater from over the South Pole over a period of a lunar year. And so you can see parts of the rim always have sunlight on them because they're on the pole, where the inside of the crater is completely shaded. And that crater is bigger than you think. I think you can fit 14 Oslos in there. It's a big crater. You should also ask the logical question, who took this picture? This is taken from the Lunar Reconnaissance Orbiter. Every time it flew past the Shackleton crater, it would take the shot. And so they gradually built up a mosaic of all of them to do an animation of what the lighting was like for the entire year and showed the power of Shackleton crater. So this is a very important location on the moon. Everything we needed to have humans survive for the Apollo missions we brought with us. Every drop of water, every scrap of food, everything. We have never, ever used resources in space. We have always brought them with us, like loading up your RV and never stopping at the gas station. The attempt to start to use resources on the moon changes the equation dramatically. We can actually extract water for breathing, and for drinking, and for rocket fuel. We carry a lot less stuff. Water's heavy. Every kilo of it weighs a kilo. There's a lot of kilos. So if we can start using local water, we get to have more room for other things. And we start being able to utilize that resources to do more in space in general. There is a proposal, it's actually an ESA proposal called Moonlight, to put up the equivalent of a GPS array around the moon. The moon's a lot smaller. Its total surface area is about the size of the United States. But it's hard to navigate on. It's also magnetically irregular and gravitationally irregular. There's a variation of gravity is more than 2%. And so it's challenging to navigate on. Getting back to the same spot is fairly tough. And so having precise navigation, this would only need about 16 satellites, and they would be a combination of navigational and communications. So we would have communications relays all the way around the moon, as well as always knowing precisely where you are. It's a pretty simple array. The orbits, I mean, that's a cool drawing. It's not remotely accurate. Because of the instability of the gravity on the moon, the orbits would be eccentric. They would pass close to the moon and then fly further away and then close to the moon. And there would be a bunch of them all doing that in different directions. It's pretty in its own way. But then you can precisely navigate. You can communicate at any point in the moon, so you have some flexibility. Now, Elon's base, you know, when I look at that, looks an awful lot. Well, I thought Burning Man. But also Space 1999. Do you remember that show? Don't ever go back and watch it again. Your memories of that show are vastly better than the show. It's kind of like Kentucky Fried Chicken. Like if you had Kentucky Fried Chicken as a kid, you thought it was great. Don't eat it today. Yeah, that TV show was terrible, but it was a moon show. The ESA proposal for building a base on the moon is way more practical, which is to say an inflatable habitat with an airlock that uses robots to bury it under the regolith to protect from radiation. You need about 1 meter of regolith over you to mitigate the amount of radiation because you're outside of the Earth's magnetic field, so you are in danger. And so protecting you is going to take a lot. That's a very practical approach. Even more practical are using skylights and lava tubes. So our friend Jack proved that there was volcanic activity on the moon. There's plenty of other evidence to it, and this is one of them. This is the Marius skylight. So ages ago, millennia ago, when there was volcanic activity on the moon, there was basaltic lava flows, and they formed tunnels as they were flowing, and as the lava retreated, it left these tunnels behind. They are large. And where they come close to the surface, occasionally they collapse to create this skylight. So this is big, about 150 meters across and at least 80 meters deep. They think the tubes could be up to 300 meters in diameter. So imagine basically landing the equipment to insert an inflatable habitat inside that lava tube. Radiation shielding built in, protection from moonquakes. That's how you build bigger space in there. And it's got a Dr. No feel to it, that you come up out of the hole in the moon. I think that's a feature, really. Mostly the work we'll be doing on the moon will be robotic. And our goal here is to learn to operate in space, to work off of the Earth's surface, to extract resources, to mine and refine, to be able to make things on the moon, again, to lower the price of it. Now, interestingly, if you look at the composite of regolith and various ore bodies that are close to the surface of the moon, which we've now mapped out in pretty good detail, we have all the ingredients to make solar panels up there. Lots of silicates, titanium dioxides, all the stuff you need. So you could make solar panels up there. The Japanese proposed, let's just wrap the moon in solar panels, which is cool. I don't know how practical it would be, but you know, there's always sun shining somewhere along the equator, so you'd be making some power. I don't know that we need that much power up there, and 400,000 kilometers is too far to beam it back to the Earth. But low Earth orbit's not too, or high Earth orbit's not too far. So what about this? You learn to survey, locate ore bodies, mine them, refine them, start manufacturing, you make solar panels. Then you use a linear accelerator to send those solar panels in bundles back towards the Earth. Not to go down to the surface of the Earth, that's a bit silly, but up into geostationary orbit, 36,000 kilometers away, where you build space-based power stations. This is a design called SBS Alpha. Now, space-based power has been proposed for a long time. It's just that it costs too much to lift it from the surface of the Earth. The moon's got a lot less gravity. It's much easier. If you can make the panels up there and fly them back here, it costs a lot less to do it that way. Because this is about 5 kilometers across. This thing's big. But it's a gigawatt of solar power that has no night. When you're in geostationary orbit, you always have sunshine. You have a rectangle at the bottom that beams the energy by microwave back to the surface, which again, very science fiction sounding, except we beam microwaves for power all the time, just not this much. The landing point would be about 10 kilometers across. Now you can walk around in there, birds won't fly in fright or anything fun like that. You would probably not fly airplanes through it, it's not a smart thing to do. You'd probably want to put a fence around this too. Like, don't walk in the microwave array. But that's zero emission energy, friends. That's a gigawatt of power onto the surface of the Earth. Pretty much anywhere you want, just build the array and power it up. The military's interested in this sort of thing. You think about how much money the Americans spend in Afghanistan just shipping fuel from Karachi to Islamabad over and over and over again. 600 trucks running 24 hours a day just to put in fuel for generators and vehicles. Or they could have had a satellite array beaming the energy down onto the surface at their base and running everything electric. Imagine this in a disaster response site, a major earthquake site. Bring power to the place, right? Maybe not quite this big. But the other thing that happens when you have a satellite like this is you can also use that power up in space as well. You know, every vehicle is a combination of a fuel, a power, some way to combust it or turn it into a power, and a motor, right? So in a chemical rocket, the fuel and the propellant is combined and burnt in an engine that's accelerated out of the back of a nozzle. In an electric spacecraft with a Hall effect thruster, you have some kind of electrical source, typical solar arrays, a fuel like xenon that you highly charge and put out of a Hall effect thruster, and that's your accelerant. But the energy source weighs a lot. So what if you put the energy source at the fixed location? Change this out for a laser, more Dr. No stuff. But now you point it at the vehicle and transmit the energy to it, so you don't have to carry that weight around. So imagine we're relaying resources from the moon and back again. One of the biggest problems you have as you come back towards the Earth is the gravity grabs it and accelerates it. And you can't go into orbit around the moon. You have to decelerate a lot. You'll just fling off, or you go into the atmosphere, which is what we currently do. So you have a big heat shield. You're going to dissipate all that energy coming back down. What if there's a couple of these there that then give you the energy? I mean, even just ablatively, right? We have a bladed block. You put a laser onto that. The energy from that sprays back, slows the vehicle down. So we start to build a transport system going back and forth. Vehicles that only have to carry the fuel and motor, don't have to carry their energy. So you can imagine different ways to allow for propulsion to move back and forth. All right. We have a lot of resources up in the asteroids, far more than we even conceive of. We still haven't mapped all the asteroids out. There are lots of different locations. Most people think about the ones between the Mars and Jupiter. There's also ones trailing and leading the Earth in the L4 and L5 points that are very easy to get to from an energy perspective. There are lots of different kinds of asteroids, right? The most common are these ones called C-types that are mostly water, but they also have a lot of various salts, potassiums, manganese, nitrogen salts, all potentially valuable for extraction. Then you have the silicate or mineral rich. This is Didymos and Dimorphos, or Didymoon as they called it, the one they collided with. And then there are the M-types. We just had a mission called Psyche to this metallic core. They think what might have been actually the core of the planet that was trying to form between Mars and Jupiter ripped it apart, because that's the problem when you have a bigger neighbor. But mostly metal and nickel, iron, and platinum class metals in these. But there's tens of thousands of these all through the solar system without even getting really out into the outer parts. So the prospect of building vehicles that can actually grab these and then extract the minerals. So typically using solar collectors as your easy energy source to vaporize a lot of the rock and then use gaseous separation. Then you'll typically do salt recombinations, things like fluorines and chlorine salts with pure elements in them, and then that creates volumes of semi-liquids that are easier to move around and easy to chemically separate for the metals that you want. They don't build bars of metal. And these would be largely autonomous. So you build them out, you just got to send them somewhere. You don't want to send them back to the Earth. Don't stick them back down a gravity well. It's problematic. So these largely have been designed and experimented with. They just haven't flown many of them because flight's still expensive. But yeah, pieces of it, that optical mining part's actually been built. And so they want to start taking small asteroids and taking them apart. And then now you got to take advantage of the minerals. Like you could bring some back to the surface. It's just an expensive thing to do, just to get back in a gravity well. But especially when we talk about platinum class metals, which we're already struggling with availability on, that's why the price keeps going up. We could be driving the price down on those with a couple of M-class asteroid extractions. And they are key ingredients to space work, right? Hafnium's getting expensive, and you need it for rocket bells. You also need it for a bunch of other industrial applications. So having access to the space-based ones make our lives a lot easier. But given we get to that point, we learn this stuff on the moon, relatively close by, in enough gravity that makes humans able to work. Now you start doing stuff on asteroids, largely with automation. You're probably going to use a base on the moon to be your landing site. The logical place for this would be on the far side of the moon. That's at a nice balance point gravitationally. It's still an easy, small amount of energy to get back to the Earth if you need to, but not a lot to stay where you are. It's also a place where you really could build a space elevator. Space elevator off the moon is easy. You can make them out of aramids. Like, you don't need exotic materials. It's not that much gravity. So you have easy access up and off the moon. Now you've got asteroids collecting resources for you, and they bring them back to the far side of the moon. And that's a good place to start building stuff from. So bigger space stations, construction yards. We always presume they'd be in low Earth orbit. It's not really a good place to do it. You're more likely to do it out on the moon. Again, because it's easy access. We're already working up there. We've built up this infrastructure already. We're coming and going from there routinely. So this is where you start getting more solar system resources into place. And it's not only low delta V back to the Earth, it's also low delta V to most of the inner planets. It doesn't take a lot of energy now to get to Mars from here. You've done a lot of the heavy lifting once you're already there. So if you were going to build a spacecraft that could take you to Mars, irrespective of what Elon wants to do, it makes more sense to assemble it in space and assemble it on the far side of the moon, so that when you actually want to go there, you don't have a huge amount of energy you have to consume to get it going. Biggest problem we've learned on the International Space Station is that humans don't do well in free fall. We only typically allow them to stay there about 6 months. At the end of 6 months, you come back to the surface of the Earth, where you are carried out of that capsule because you can't walk, your feet hurt, you haven't used them in 6 months, and you're in for a year of rehab. Your body has changed. You've been exercising 2.5 hours a day every day on the space station to lower the amount of bone loss. So you're only lost maybe 1 or 2% of your bones, but it's going to be hard to get that back. Most of your bodily functions function in free fall, like all your digestive systems and all of the peristaltic pumps, your blood and so forth work. Burps don't work. There's a way, I've seen it demonstrated, where they back up against the wall of the space station, and then you accelerate so all the food goes down the stomach, and then you can burp. And if you get it wrong, you have to clean it up. But one thing that doesn't work is cerebrospinal fluid. So you have 2 little organs inside your brain that produce a liquid that bathes your brain. It actually cleans your brain, right? As neurons die and there's various detritus and so forth, the cerebrospinal fluid picks all that up, and it flows down into your spine. And then it does a membrane exchange with your blood through your urine to maintain cerebrospinal fluid. And bedridden patients, we've learned, have to be sat up every day. And one of the reasons you sit them up every day is cerebrospinal fluid. If they stay laying down all the time, fluid collects too much in their head. It's hard on them. And so just sit them up every day. Gravity does its thing and moves the cerebrospinal fluid. Well, this doesn't work in free fall. You'll notice that the astronauts on the space station are all pretty puffy-faced. They're also all wearing glasses, which is weird. They're astronauts. Aren't their eyesight supposed to be perfect? But one of the problems that happens is the fluid builds up in your head so much, it presses against your eyes, and it bends your eyeballs. And so they have different pairs of glasses depending on what pressure level's in their head, because their eye shape changes. And then when you go back down, all of this has to recover, which is why it takes a year to recover. Which begs this question: if we sent a bunch of astronauts in free fall all the way to Mars, which takes 6 months, then they get there and then land, then what? There's nobody there to help them. You get a rehab on your own? So we need to experiment. We need to figure out artificial gravity. And we don't get to do science fiction artificial gravity. We have to do real artificial gravity. We need to build a rotating structure. Now, centrifuges are easy. If you've gone to the amusement park where they have that spinning machine where everybody's pressed against the wall, that's basically it. One of the things you learn is to be comfortable, the gravity differential between your head and your foot has to be less than 1%. So I can't build a small rotating structure, because then the gravity differential between my feet and my head will be large. To make something comfortable at 1G, it's got to be about 100 meters in diameter. And then it can rotate at about 3 RPM, and the gravity differential between my foot and my head, if I was 2 meters tall, which I'm not, would be about 0.5%. That would give you 1G. Never built anything that big before. We've never rotated a structure that big before. It's not that we can't, we just don't know how. We haven't done it. There's all kinds of, then you got to move that thing, right? Like, none of this is trivial. And it's also a question of, does it have to be a G? Could it be less? We've never experimented with that. One of the things we could do on the moon, where it's 1/6G, is actually do long duration experiments on humans at 1/6G. Is that enough to keep the fluid moving enough? Can they stay healthy? What's their bone loss like? Because if it only had to be 1/6 of a G, we can build a smaller wheel for that. It'd be a whole lot easier to build. Now, in science fiction, we've built a few of these. This is a proposal called Nautilus X, which is largely based on space station components with the rotating inflatable sphere donut there. That's never been made. This hasn't been made either, but it's got better footage. This is from The Martian, right? This is the Hermes. Actually, there's really well thought out stuff in The Martian. Like the dust storm's stupid. The Iron Man thing's extra tasty stupid. But this spacecraft's pretty well thought out. Non-rotating parts in the center. A little bit of solar for power. Most of these are actually radiators for a thermonuclear power plant in the back. And then there's a rotating structure in the center, but it's not a complete ring. It's 4 chambers, so they balance each other, about 100 meters in diameter, rotating at 3 RPM. But the math tells us to create 1G, which is a good idea. A couple of interesting problems you have to think about on this. Like, it's good to have gravity, especially good for you to sleep in gravity, but you also need to transition to free fall every so often to do work in different parts of the ship. And virtually every normal functioning human is nauseated in free fall for the first day, sometimes 2. So imagine transitioning back and forth between gravity and free fall every day. I hope you get good at it, because that's going to suck. But these are the experiments we would do with these next generation of space stations, right? Is now let's build a couple of centrifuges and start working on systems. There was a proposal to put a centrifuge on the International Space Station that got scrapped because it screws up all the microgravity experiments. It shakes the whole station. They don't mix. More smaller stations. Anyway, once you figure out these rotating structures, I'm just putting all the ingredients together for you for where we can end up at. We've learned to extract resources from the moon. It's led us to extract resources from the asteroids. Now we can start to build stuff in space. A vehicle this large, we're probably going to build a lot of it in space. The electronic bits, okay, we'll probably build that down inside a gravity well, but whatever we can build in space, we will. And you solve the rotations problem and understand it. You know, there's a logical extraction from here. Like, why go to Mars? Why go back into a gravity well? It's kind of daft. To get minerals, you already had to get minerals in space to build the thing in the first place. Why would you get minerals down there? Why don't we just keep building? We already know how to build. Just build bigger. So that's the O'Neill cylinder. Named for Gerald O'Neill, who proposed it in the 1970s with what he called the L5 colonies. So now we're talking about building something 5 kilometers long, 1 kilometer in diameter, rotating very slowly, but enough to create a normal gravity well on the inside of the surface. So inside, you're living in a city. A couple of million people can live inside of one of these. We have the materials. You can put them where you want. Arguably, I would put them closer to the sun than the Earth. I put it like almost near Venus's orbit. A lot more solar power that way. But and you can build hundreds of thousands of these. And when you want to go back into space, you take an elevator. You just go back to the central axis, and you're in free fall, out to the control ring, and off you go where you want to go. You're not confined for space, right? We can have trillions of people living in this solar system if we put them in spaces like this. It's just a set of steps. The set of steps we're on. Each one of these steps that we're working on in the moon to go through these ingredients to start to be able to do these extractions. This is the destination. This is what you can get to. And it opens the door to a number of other options past that. Different places to live, different worlds to explore. Certainly spend more time on the solar system. Like going and inhabiting Mars, I kind of want to explore Mars as it is before we try and make it us. Let's make our own habitats, and then we have a chance to explore all the solar system. There's lots more things to see. And beyond that, who knows? I hope this was fun for you. I love telling these stories. If you go to geekout.show, that'll give you a list of all the .NET Rocks episodes that are Geek Outs. There's about 100 of them. I hope you have a great conference. Thank you so much for coming out.